Introductions to mathematical statistics, and then today we'll be going to probability set function. My name is Swandolo Afemi, a PhD student in Department of Mathematical Sciences. Alright, before we go fully through the definitions, let's first of all define a sigma field. So definition: let X be a collection of subsets of our sample and C. So we say X is a sigma field if it satisfies this following condition. 1. This empty set, it contains empty set. 2. If C is an element of sigma field, then the complement also must be in our sigma field. In other words, we see our X is closed under complement. And then in 3, if the sequence of set C1, C2, is in our sigma, then the union I equals to 1 to infinity of Cn also must be in the sigma. So in other words, we say that our sigma is closed under countable unions. Okay, so let's give some example of a sigma field. Example: so for any C that belongs to column C, which is our sample space, we can write our sigma field as C, the complement of C, the empty set, and then the full set can be C. So this is sigma field. Another example is a sigma field because if you take the union of any set here, the result also will still be here. And then we can also verify all those three properties. This empty set, the full set is there, the countable union is closed under countable union, is also closed under complement. And then let our fancy C be a collection of sets, and our sigma be the collection of all subsets of our column C. So then our X is a sigma field, and this is called the power set of C, and this is the largest possible sigma field you can generate by that set. So the smallest possible sigma field that has to do with the intersection So let it be a non-empty collection of subsets of policy. So let our sigma to be intersection of epsilon such that this subset of epsilon, and epsilon is a sigma field. So then X is a sigma field. So, and this is the smallest sigma field which contains D. Hence it is referred to sigma field generated by D, and then sometimes we call it Borel sigma field and also. Then with that, now we can now define what an event is. So definition: let X be a sigma field on a sample space C. So C is called an event if C belongs to the sigma field. Okay, that the elements of sigma's field are called an event. Any element in the sigma field is called an event. So then another definition: so now I want to define our probability. Let policy be a sample space and then X be a sigma field on our policy. So let P be a real valued sect function defined and sigma. So then P is a probability if P satisfies these three conditions. For P to be a probability 1, for all C or the event is sigma field, the probability of C will always be greater than 0, which is also known as non-negativity. And then 2, the probability of the whole Corley set C must be equals to 1. And then lastly, if we have a sequence of an event in sigma field and they are disjoint, then the probability of the sequence n equals to 1 to infinity is equal to the sum of the probability. So these three conditions must hold. Then we consider P is probability. So let's check some basic theorem. Properties. Of probability. we have the following theorem. For any C that belongs to sigma field, the probability of C complement is equal to 1 minus probability of C. That the probability that an event will not occur is 1 minus the probability that the event will occur. So you can actually prove that. Then theorem 2 under properties. For any C that belongs to sigma field, the probability of C is always between 0 and then 1. So the probability of an empty set is 0. Should be 3. So then 4, if C1 and C2 are events such that C1 is a subset of C2, then the probability of C1 or less than or equal to the probability of C2. Okay. Then 5, if C1 and C2 are events in our sigma field, then probability of C1 union C2 got the probability of C1 plus probability of C2 minus the probability of the intersection. And then 6, we have what we call Ben-Forening inequality. So we have probability of C1 intersection C2 is greater than probability of C1 plus probability of C2 minus 1. Okay, then we have inclusion and exclusion formula. So probability of C1 union C2 union C3 is equal to probability P1 minus P2 plus P3, and our P1 is equal to probability of C1 plus probability of C2 plus probability of C3, and then P2 equals to probability of C1 intersects probability of C2 plus probability of C2 intersects C3 plus probability of C1 intersects C3, and then P3 equals to probability C1 intersects C2 intersects C3. Okay, so then for nth number of events, we have P1 minus P2 plus P3 minus dot plus minus 1 n plus 1 P of n. So let's check some useful inequalities. Okay. we have bullish inequality. Probability of C1 union dot union Cn is less than probability of C1 plus dot plus probability of Cn. So let's check some example. We have let our policy denote the sample space inducing a pair of fair die, and let C1 equals to 1, 1, 2, 1, 3, 1, 4, 1, and then 5, 1. So we have C2 to be equals to 1, 1, 2, 2, 3, 2. So we have to find PC, 1, PC, 2, PC 1 union C2, and PC intersection C2. So for the first one, so we know that the total number of sample space we have inducing a pair of fair dice is 36. So then probability of C1 is we have 1, 2, 3, 4, 5. So that will be 5 over 36 because we have 5 numbers of A and then the total number is 36. Our probability of C2, that is 3 over 36, and probability of C1 union C2 by the law of inclusion is to find the probability of C1 plus probability of C2 minus probability of C1, and that's it, C2, except there's no inclusion. So probability of C1 and C2, so we can find probability of C1 and that's it, C2. And then we have how many? We have 1 here, 1, 1, 1, 1, and that is the only inclusion. So that's 1 over 36. So that means that we have 5 over 36 plus 3 over 36 minus 1 over 36, and that is 7 over 36. So, and this last one actually gives us 1 over 36. Okay. Then we can also check another example. So check this example. So we have two fair coins are to be tossed, and the outcome is the other pair face on the first coin, fixed on the second coin. What is the sample space? What is the property set function on C? And let C1 equals to H, T, and C2 equals to that. Calculate P1, C1 union C2. So let's first of all add the partition. So we have two fair coins, that means that we can have all the possible sets we can have, and that will be the sample space. So First, we can have, since it's 2 fair coin, we can have head, or we can have head tail, or we can have tail head, or we can have tail tail. So those are the 4 possible solutions that we can have. Okay. So the probability of C1, we have head and head tail, and that will be equal to 2/4, and that is half. A probability of C2 also 2/2, which is equal to half, and the probability of C1 C2, that is the probability of C1 plus probability of C2 minus probability of C1 intersect C2. So we need to first of all find the intercept. Probability of C1 intersect C2 is because what they have in common, they have head only in common, and that is 2/4, and that is half. So then the probability of C1 C2 equals to probability of C1, that is half, C2 half, and then half. So we have half as our result. So with that, we can, in our next class, we try to check mutual exclusion and then equality cases, and then we go to the country rule. So hope to see you in the next video. Thank you.